Welcome once more to the dark. The ground beneath you is moving at 1674 kilometers per hour. You cannot feel it. You never could. At the poles, the ground moves nowhere at all, but here, the surface of the Earth is already spinning faster than the speed of sound, carrying you with it, in perfect silence. Tonight, I want to show you that the ground beneath you has never once been still, and that the same silent law turning the Earth is the reason the galaxy, the stars, and every atom in your body have been spinning since long before any of them had a name. Before you leave a small light behind with a like or a subscription, know this: you are already spinning. The ground beneath you moves at 1674 kilometers per hour, carrying you eastward at a speed you cannot feel and never could. At the poles, the ground moves nowhere at all. This motion will not stop. Not tonight, not in a billion years. The universe has no mechanism to make it disappear. Lower the lights, put on your headphones, and let yourself drift while we follow this turning to its origin, through collisions that rewrote the length of the day, to galaxies that turn so slowly you could sleep a million years and miss nothing. I am the cartographer of the dark, and I have been mapping these distant places for longer than I can remember, tracing the paths of things that turn and never stop turning, following the invisible thread that connects your body to the spin of galaxies. The ground beneath you is moving at 1674 kilometers per hour, not shaking, not trembling. Moving in a smooth arc through space, carrying you eastward at a speed faster than the fastest jet, and you cannot feel it. You never could. Everything around you moves at exactly the same rate: the air, the walls, the bed, your own body. All of it locked into the same rotation, synchronized so perfectly that the motion becomes invisible. At the poles, the ground moves nowhere at all. A point at the true North Pole simply rotates in place, turning like the tip of a spinning top that never travels. But here, wherever you are lying now, the surface of the planet is sweeping you through space at a speed that would tear the sky apart if you could see it happening. You have been moving this fast since the moment you were born. Before that, in fact, before anyone was born. Before the first cell divided in the first ocean. The Earth has been turning at this speed for more than 4 billion years, and it will not stop. NASA has calculated the probability of Earth ceasing its rotation in the next several billion years as practically zero. Not unlikely, not improbable. Practically impossible. This is not a choice the planet is making. It is not an engine that might run out of fuel. The spin is not something the Earth does, it is something the Earth is. Lower the lights. Put on your headphones. If you would like to follow this rotation from the ground beneath you all the way to the edge of the galaxy, subscribe to Sleep Among Galaxies. We map the invisible architecture of the cosmos, one slow turn at a time. The reason the Earth cannot stop spinning is the same reason the star collapses into a neutron sphere no wider than a city and begins rotating 700 times every second. The same reason the Milky Way turns so slowly that the Sun will not return to this exact position in space until 225 million years have passed. The same reason every planet in the solar system orbits the Sun in the same direction, tracing the same flat plane through space. There is a law older than the oldest star. It has no exceptions. Angular momentum can move from one object to another, but the universe has no mechanism to make it disappear. Every unit of spin that has ever existed still exists. The cosmos remembers. In 1918, a mathematician named Emmy Noether proved this is not a rule someone invented. It is a consequence of the shape of space itself. The laws of physics are identical no matter which direction you face. North, south, east, west. That symmetry means angular momentum cannot be destroyed. It is woven into the geometry of the universe. Even a jagged, broken rock tumbling through the dark obeys this law perfectly. It is not the object that needs to be symmetric, it is the space through which it moves. The Earth is not choosing to spin. It is obeying a law it cannot break. When you stand still, you are not still. When you lie down to sleep, you are not resting. You are moving at 1,674 kilometers per hour, and that motion is older than mountains. It is older than oceans. It is a memory the planet carries from the day it formed, and it will carry that memory until the sun expands and swallows the inner planets whole. The spin you cannot feel is the same spin that shaped the solar system. It determined where the planets would form, how fast they would orbit, and in which direction they would travel. It made the Earth a sphere instead of a cloud. It gives you day and night, sunrise and sunset, the passage of hours you have measured your entire life. And it all began with a cloud. Billions of years ago, before the sun existed, there was only a diffuse mass of gas and dust drifting through interstellar space. It was several light years across, cold, dark, nearly empty. But it was not perfectly still. Nothing in the universe is perfectly still. The cloud had inherited a small amount of rotation from the motions of the stars and gas clouds that had come before it. Just a slow, lazy turn. Then gravity began to pull the cloud inward. As the cloud contracted, it had to spin faster. Not because something was pushing it, not because energy was being added, but because the universe could not forget the spin it already had. The cloud was shrinking, and the only way to keep the total angular momentum intact was to rotate faster. The same principle governs a figure skater pulling in her arms. The same principle governs a collapsing star. Material near the poles of the collapsing cloud fell almost straight inward, drawn by gravity toward the center. But material near the equatorial plane could not fall in a straight line. It was moving too fast. It could only fall sideways, spiraling inward, flattening into a disk around the growing protostar at the center. That disk became the solar system. Every planet formed from that same rotating disk, every asteroid, every comet. They all orbit the same way, because they all remember the same motion. The direction was chosen billions of years ago, and it cannot be unchosen. The Earth inherited its spin from the cloud, but something changed its rotation rate. Approximately 4.5 billion years ago, a body the size of Mars struck the early Earth at an oblique angle. The leading theory holds that this collision between Earth and an object we now call Theia ejected enough molten rock and vapor into orbit to form the Moon. The impact also tilted the Earth's axis to 23.5 degrees. That tilt is what gives us our seasons. Without that collision, the Earth might have no axial tilt at all. No summer, no winter, just an endless, unchanging cycle of identical days. Immediately after the impact, the Earth was spinning so fast that a single day lasted only 5 hours. 5 hours from sunrise to sunrise. The sky would have been a blur. The Moon, newly formed and still glowing with the heat of its creation, would have loomed enormous in the sky, closer than it has ever been since. The tilt that gives us our seasons is the scar of that collision. The Moon itself is the scar, and every sunrise you have ever seen carries the memory of that day when two worlds collided and became one. The Moon is still rewriting that memory. Its gravity pulls on the Earth's oceans, dragging them into tidal bulges. Because the Earth rotates faster than the Moon orbits, the tidal bulge sits slightly ahead of the Moon in its orbit. The Moon pulls back on that bulge, slowing the Earth's rotation. The day is lengthening. Not quickly, not noticeably, but measurably. approximately 1.7 milliseconds per century. At that rate, it will take 200 million years for a day to reach 25 hours. 400 million years ago, a day on Earth lasted only 22 hours. There were more than 400 days in a year. We know this because ancient coral fossils preserve growth rings, one ring per day, and we can count them. Physical proof that time itself was different. The Earth has been slowing down for as long as the Moon has existed, and it will continue slowing until, billions of years from now, the Earth shows the same face to the Moon at all times. The Moon has already arrived at the destination the Earth is slowly moving toward. Angular momentum does not disappear, it only moves. The Earth is losing rotational speed, but the Moon is gaining orbital distance. The total angular momentum of the Earth-Moon system remains exactly the same. The universe remembers. I wonder where you are tonight, and what the sky looks like from there. The stars shift their shapes depending on where you stand on this turning world. If you'd like to leave your city and your local time below, I'd be glad to know. Long before the first star ignited, before the first galaxy formed, before there was anything in the universe capable of witnessing motion, the law was already written into the fabric of space itself. Angular momentum cannot be destroyed. It can move from one object to another, but the universe has no mechanism to make it disappear. This is not a rule that physics discovered and then decided to follow. It is older than discovery. It is the shape that possibility takes. In 1918, a mathematician named Emmy Noether proved this is not a rule someone invented. It is a consequence of the shape of space itself. She showed that if the laws of physics remain identical no matter which direction you face, then angular momentum must be preserved. The two facts are inseparable. One demands the other. The law is not optional because the symmetry of space is not optional. Einstein praised her work as an example of penetrating mathematical thinking, and today it is a standard tool of theoretical physics. But the theorem itself requires no classroom. It is true in the void between galaxies. It is true inside the core of a collapsing star. It is true in the empty reaches where no light has ever traveled. Even a jagged, broken rock tumbling through the dark obeys this law perfectly. The rock does not need to be smooth. It does not need to be spherical. It does not need to know the law exists. The law does not care whether the object is symmetric. It cares only that the space through which the object moves is symmetric, and space always is. An irregular asteroid spinning end over end through the outer solar system, its surface scarred by 1 billion years of collisions, its shape twisted and asymmetric, still preserves every unit of angular momentum it has ever received. The chaos of its tumble is not chaos at all. It is memory rendered in motion. This is what makes the spinning different from other kinds of movement. You can stop walking. You can bring a car to rest. You can let a thrown ball fall to the ground and lie still. But you cannot stop the spin without giving it to something else. The energy can dissipate. The object can slow. But the angular momentum must go somewhere. It can hide in the orbit of a moon. It can transfer to a companion star through streams of falling gas. It can spread across a disk of debris or concentrate in the collapse of a core. But it cannot vanish. The ground beneath you turns at 1,674 kilometers every hour, because the Earth inherited that motion billions of years ago, and the universe remembers. The Moon pulls at the oceans and slows the day by fractions of a millisecond each century, but it does not erase the spin. It only moves it elsewhere. The angular momentum that once belonged entirely to the Earth now lives partly in the Moon's orbit, transferred across the gap between them through the patient drag of tides. Nothing was lost. Nothing ever is. When the solar nebula began to collapse, it was a cloud of gas and dust several light years across, drifting slowly through the dark. It had inherited a small amount of rotation from the motions of the stars and clouds that had come before it. That rotation was almost negligible, but as gravity pulled the cloud inward, the spin could not be lost. The cloud contracted. The rotation accelerated. What had been a gentle drift became a faster turn. And then, faster still, because the universe had no way to let the motion go. Material near the poles fell straight down toward the center, but material near the equator could not. It was moving too fast. It could not fall in a straight line. It could only fall sideways, tracing a tightening spiral, flattening into a disk that spun faster with every passing century. The disk became the birthplace of planets. Every world that orbits the Sun today moves in the same direction, in nearly the same plane, because they all remember the same original spin. When Theia struck the early Earth 4.5 billion years ago, the collision did not create new angular momentum. It redistributed what already existed. The impact was oblique, angled, and it sent a spray of molten rock and vapor into orbit. That debris carried angular momentum away from the Earth and into the ring of material that would become the Moon. The Earth's day, which had been longer before the collision, became a 5-hour spin in the aftermath. The tilt that gives us our seasons is the scar of that collision, written into the angle of the axis and preserved ever since. The Moon formed from that ring, and it has been pulling back on the Earth ever since, slowing the rotation by fractions that accumulate across the ages. 400 million years ago, a day lasted only 22 hours. There were more than 400 days in a year. We know this because ancient coral fossils carry growth rings that record the rhythm of the tides and the passage of days, and the rings do not match the present. The coral remembers a faster Earth. The Moon has already arrived at the destination the Earth is slowly moving toward. It shows the same face at all times because its rotation and its orbit have become one. When a massive star's core collapses to a sphere 20 kilometers across, all of the angular momentum that once belonged to an object, hundreds of thousands of kilometers wide, is compressed into that tiny remnant. The universe simply remembered every unit of spin the star ever had and compressed it into 20 kilometers. The neutron star that results can rotate hundreds of times each second because the collapse left it no other option. The fastest confirmed pulsar, catalogued as PSRJ 1748 to 2446 AD, rotates 716 times every second, with a regularity so perfect that when the first pulsars were discovered, astronomers provisionally labeled them LGM for little green men, before the natural origin was identified. Some neutron stars rotate slowly, only a few times each second, because they formed alone. Others rotate hundreds of times faster because they have companions. A companion star can transfer angular momentum across the gap between them, feeding the neutron star with streams of gas that spiral inward and accelerate the rotation. The spin is not violence, it is accounting. The universe tracks every transfer with perfect fidelity. The Milky Way turns so slowly that one full rotation takes 225 million years. The Sun moves along its orbit at 230 kilometers every second, but the path is so vast that the motion feels like stillness. The last time the Sun occupied this exact position in the galaxy, dinosaurs had not yet appeared on Earth. The galaxy will complete its turn long after every structure we have ever built has returned to dust. Stars near the outer edge of the galaxy orbit at nearly the same speed as stars closer to the center. By the gravity of visible matter alone, the outer stars should move much more slowly. They do not. Something invisible holds them in place. We call it dark matter because we have no better name for what we cannot see. But whatever it is, it obeys the same law. It spins, it remembers. It transfers angular momentum just as visible matter does, because the law does not distinguish between what we can see and what we cannot. The law was there before the first galaxy formed. It will be there when the last one goes dark. It does not require witnesses. It does not require understanding. It simply is, woven into the symmetry of space, older than time, patient as the void. The cloud that became your world did not fall the way a stone falls. 4.5 billion years ago, before the sun existed, before the planets had names, there was only a cloud of gas and dust drifting through the dark. It stretched across several light years of space, wide enough that light itself would take years to cross from one edge to the other. If you could have held that cloud in your mind all at once, it would have looked like fog, threadbare and cold, so thin that a handful of it would contain fewer atoms than the breath you just took. And yet it was already spinning. Not quickly, just enough that if you could have stood at its center and watched a single particle of dust, you would have seen it trace a slow, patient curve against the stars. Then gravity began to pull the cloud inward. The collapse took millions of years. Material drifted toward the center, drawn by its own mass, and as the cloud shrank, something inevitable happened. It began to spin faster, not because anything pushed it, not because energy entered from outside, but because the spin it already carried had nowhere else to go. The cloud grew smaller, and the motion that had been spread across light years compressed into a tighter and tighter circle. A figure skater pulls her arms inward, and her body turns faster, though her muscles add no new force. The principle is the same. The spin was already there. It simply moved inward with the mass. In 1796, a mathematician named Pierre-Simon Laplace showed that this acceleration is not optional. If a rotating cloud contracts, it must spin faster. The mathematics left no room for exceptions. A decrease in size demands an increase in rotational speed, because the total angular momentum of the cloud cannot be destroyed. It can only redistribute itself. Laplace proved this not by watching clouds collapse, but by tracing the logic of motion itself. The law was there whether anyone saw it or not, so the cloud spun faster. But not all of the material could fall straight down. Near the poles of the collapsing cloud, gas and dust drifted directly inward, pulled along the axis of rotation. There was nothing to stop them. They fell the way you expect things to fall, drawn by gravity toward the center. But near the equator, the material was already moving sideways, carried by the spin of the cloud itself. As gravity tried to pull it inward, that sideways motion resisted. The particles could not fall in a straight line. They could only fall sideways, curving into orbit around the growing center, tracing paths that bent under the tension between inward pull and inherited motion. And so the cloud flattened. What had been a sphere became a disk. A wide, rotating plane of gas and dust, glowing faintly in the infrared, circling a dense knot of heat and pressure that would one day ignite as the sun. The disk was thin compared to its width, like a coin spinning in the dark, and everything in it moved the same way. The same direction. The same plane. Because it was all part of the same original spin. Once the cloud began to contract, the spin it carried forced it into that shape. The poles could fall inward, but the equator could only fall sideways, and so the cloud flattened, and the geometry of its collapse wrote the future of everything that would form inside it. The planets formed inside that disk. They coalesced slowly, over tens of millions of years, from collisions between dust grains that stuck together and grew. Pebbles became boulders. Boulders became mountains. Mountains became worlds. And every one of those worlds inherited the motion of the disk that made it. They did not choose their orbits, they were born into them. That is why every planet in the solar system orbits the sun in the same direction, not because they agreed. Not because some organizing force arranged them, but because they all remember the same original spin. The cloud that fell sideways 4.5 billion years ago is still falling, and the planets are the memory of that motion. Mercury circles the Sun in 88 days, a tight, fast loop close to the fire. Venus takes 225. Earth takes 1 year, tracing the same ellipse it has traced since the disk solidified beneath it. Mars, Jupiter, Saturn, the ice giants farther out, all of them turn the same way, in nearly the same flat plane, because the disk was flat and the disk was turning and there was no other way for them to form. The angular momentum of the original cloud did not vanish when the cloud collapsed. It could not vanish. It simply moved into the objects the cloud became. The spin that once belonged to a structure light-years wide now belongs to 8 planets, hundreds of moons, millions of asteroids, all turning in the dark, each one carrying a fraction of the original motion. If you could rise above the plane of the planets and look down, you would see them all turning like the hands of a clock, orderly and parallel, their orbits nested inside one another. The Sun rotates in the same direction at the center, a slow roll that takes 25 days at the equator. Most of the moons orbit their planets in that same direction. Even the asteroid belt, that rubble-strewn ring between Mars and Jupiter, circles the same way, a river of stone flowing in the path the disk carved out. There are exceptions. A few moons orbit backward, a few asteroids tilt wildly out of the plane, but these are the results of later collisions, later transfers of momentum. They do not erase the pattern. They only add to it, small revisions written over the original text. The disk itself is long gone, the gas dispersed. The dust either clumped into planets, or was blown away by the young sun's radiation. But the motion of the disk remains, encoded in the orbits of everything it left behind. The solar system is a fossil of the cloud that made it, and the fossil is still turning. This is not a story about creation. It is a story about inheritance. The cloud did not decide to become a disk. It had no choice. Once it began to collapse, the spin it carried forced it into that shape, and the Sun formed at the center, and the planets grew in the spinning rubble around it. Every stage followed from the stage before, each one as inevitable as water finding its level. And because the law that governs angular momentum allows no exceptions, this same process has happened around every star that ever formed from a collapsing cloud. Wherever you find a young star, you find a disk. Wherever you find a disk, you find the possibility of planets. And wherever planets form, they inherit the spin of the cloud that made them. Astronomers have seen these disks around other stars. Hundreds of them. Thousands. Flat planes of dust glowing in the infrared, circling stars so young they have not yet finished gathering their mass. Some of the disks are edge-on, thin bright lines cutting across the dark. Some are face-on, wide spirals with gaps where planets are already carving out their orbits. Every one of them is a cloud that could only fall sideways. Every one of them is writing the same story our solar system wrote, in the same script, governed by the same silent law. The process is slow, patient, inevitable. A cloud drifts through space for millions of years, spinning almost imperceptibly. Then it begins to collapse. The collapse takes millions of years more. The disk forms. Planets grow. And by the time the disk clears and the planets settle into their final orbits, tens of millions of years have passed. And the spin that started it all is still there, undiminished, divided among the objects the cloud became. The ground beneath you now, turning at 1,674 kilometers per hour, is part of that motion. Earth did not start spinning on its own. It inherited its rotation from the disk. and the disk inherited it from the cloud, and the cloud inherited it from whatever larger structure it condensed out of. An unbroken chain of spin that has never been destroyed, because the universe has no mechanism to destroy it. Every orbit, every rotation, every moon circling every planet, all of it is the same motion, passed from object to object, rearranged but never lost. The cloud fell sideways because it had to, because the spin it carried and the gravity that pulled it inward left no other path. And in falling sideways it became everything you see when you look up at night. The planets, the orbits, the orderly turning of the solar system, all of it flowing from a single fact. Angular momentum moves between objects, but it does not disappear. The cloud is gone. The motion remains, and you are standing on one of the pieces. The collision happened 4.5 billion years ago, when the Earth was still molten, and the sky had no moon. A body the size of Mars, moving through the young solar system on a trajectory set by the collapse of the same cloud that formed everything here, struck the Earth at an angle shallow enough to glance, rather than destroy. The leading theory holds that this object, named Theia after the Greek goddess who gave birth to the moon, hit at approximately 45 degrees, a geometry that determined everything that followed. The impact did not annihilate the Earth, it changed it. Theia's iron core sank into the Earth's own molten interior. The outer layers, superheated rock and vapor, exploded outward into a disk of debris that began orbiting the young planet. The material was molten, glowing, a ring of liquid stone suspended in the vacuum where moments before there had been only the Earth and Theia as separate bodies. Within perhaps a few thousand years, that disk condensed. Gravity pulled the fragments together. They collided, merged, cooled into a single spherical body. The moon you see tonight is not a companion that arrived from elsewhere. It is a scar made solid, the memory of a collision rendered permanent. Before the impact, the Earth might have spun differently. It might have stood upright, its axis perpendicular to the plane of its orbit, turning without seasons, without variation, a world of eternal sameness. The collision changed that. Theia struck with enough force, and at the right angle to tilt the Earth's axis to 23.5 degrees, the angle it still holds today. That tilt is what gives the Earth its seasons. Summer and winter, the migration of sunlight across latitudes, the rhythm of harvest and dormancy, the angle at which shadows fall in June and December. All of it follows from the geometry of a collision that happened when the solar system was still learning its shape. The tilt that gives us our seasons is the scar of that collision. Immediately after the impact, the Earth spun faster than it does now. The canonical computational models describe a day that lasted only 5 hours. 5 hours from sunrise to sunrise. The Earth turned so quickly that the sky would have blurred. If there had been eyes to see it, there were no eyes. There was only motion, inherited from the cloud, transferred through the collision, and carried forward into the object the Earth was becoming. The ground beneath a newborn planet moved faster than any wind moves today, faster than sound travels through air, a rotation so rapid that the equator bulged outward under the centrifugal strain. The debris disk that became the moon began its existence close to the Earth, perhaps 15,000 kilometers away, a distance you could cross in a commercial airliner in less than a day if the airliner could survive the heat and the vacuum. The moon has been moving away ever since, not because it chose to leave, but because angular momentum, once distributed between two objects, must be accounted for. The Earth's spin slows, the moon's orbit widens. The total amount of spin in the system remains exactly what it was the moment Theia struck. The universe remembers every unit of motion it was given, and it has no mechanism to make any of it disappear. The moon did not invent this memory, it inherited it. Theia inherited its trajectory from the collapse of the solar nebula. the cloud that could only fall sideways, the rotating disk from which every planet in this system was born. The nebula inherited its spin from the interstellar medium, from the turbulence of earlier stars and earlier collapses, a chain of inheritance reaching back to the first asymmetries in the early universe. Every object turning tonight carries the exact record of what happened to it, and what happened to the objects that made it, and what happened before that. Angular momentum is not a force. It is a record. It is the cosmos keeping a ledger that cannot be erased. You cannot see this record directly. You cannot feel the Earth's rotation beneath you, even though the ground at the equator moves at 1,674 kilometers per hour. You cannot sense the slow drift of the moon away from the Earth, a motion measured in centimeters per year, imperceptible across a human lifetime. But the record is there. It is written in the length of the day, in the height of the tides, in the axial tilt that makes December cold and July warm. Every sunrise carries the memory of the collision. The light arrives at an angle because Theia struck at an angle. The day lasts 24 hours instead of 5, because the moon has been pulling on the oceans for 4.5 billion years, slowing the Earth's spin, transferring angular momentum from the planet to the orbit, rewriting the record incrementally but never erasing it. Coral fossils from 400 million years ago show growth rings that correspond to days. The rings are narrower than they would be today, packed more tightly, because the days were shorter. A year 400 million years ago contained more than 400 days, each lasting approximately 22 hours. The coral did not know it was recording time. It simply grew in rhythm with the tides and the light, and the rhythm was faster then. The moon was closer. The Earth turned more quickly. The record is written in calcium carbonate, in layers you can count with a magnifying glass, physical proof that time itself was different. You can hold a piece of ancient coral in your hand and see, etched into its structure, that the planet once turned faster. The evidence is not theoretical, it is tactile. The moon has already stopped rewriting its own record. It shows the same face to the Earth at all times, locked in place by the same tidal forces it exerts on the Earth. The moon reached this destination long ago. The Earth is moving toward the same destination, slowly, at a rate of approximately 1.7 milliseconds per century. At this pace, it will take 200 million years for a day to lengthen to 25 hours. The process is so gradual that no human lifetime will ever measure it. But the moon is patient. It has been pulling on the Earth since the debris disk condensed. It will continue pulling until the Earth too shows only one face to the moon, and the two objects turn together as a single system, their spins locked, their orbits synchronized, the memory of the collision finally resolved into mutual motion, two bodies turning as one. The collision is not the only memory the Earth carries. The tilt of its axis, the length of its day, the presence of the moon itself, all of these are records written by Theia. Without that collision, the Earth might have no axial tilt. It might spin upright, its poles aimed perpendicular to the plane of the solar system, a world without seasons. Life, if it arose at all, would have faced a different rhythm, a sameness that offered no reason to migrate, no pressure to adapt to cycles of warmth and cold. The collision did not create life, but it created the conditions in which life could diversify, could learn to migrate and hibernate and bloom. Every autumn leaf falling tonight falls because Theia struck at 45 degrees 4.5 billion years ago. Every bird that flies south for winter follows a pattern made possible by a collision that happened before the continents existed. The moon is not the only object in the solar system that remembers a collision. Every planet, every moon, every asteroid carries the record of the impacts that shaped it. Mercury's iron core is disproportionately large, evidence that a collision stripped away much of its outer layers early in its history. Uranus spins on its side, its axis tilted 98 degrees, almost certainly the result of a massive impact during the solar system's formation. The planet rolls along its orbit like a wheel rather than spinning like a top, and its seasons last decades because of it. Every irregularity, every tilt, every eccentric orbit is a record. The solar system is not a smooth, symmetrical machine. It is a collection of memories, each one written by motion that could not be destroyed, only transferred. The Earth turns tonight at the same speed it turned this morning, minus an imperceptible fraction of a millisecond. The Moon drifts outward at the same rate it drifted yesterday, a few centimeters farther from the planet it was born circling. The Sun rises tomorrow morning at an angle determined by a collision that happened when the Earth was too young to have oceans. The record is being rewritten, slowly, but the total amount of spin in the Earth-Moon system remains exactly what it was the moment Theia struck. The universe has no eraser. It only has ledgers. Every sunrise carries the memory of a collision, and every object turning in the dark tonight is a page in a book that was opened 4.5 billion years ago and will never be closed. You are standing on one of those pages now. The ground beneath you is moving because Theia moved. The seasons change because Theia struck at an angle. The Moon pulls the tides because it was born from the same impact. The memory is everywhere. It is in the sky. It is in the length of the day. It is written into the structure of time itself. The Moon is slowing everything down. Not quickly, not in any way you could measure in a single lifetime. But the pull is there, constant and patient, rewriting the length of your day one invisible fraction at a time. The Moon's gravity reaches across the gap between worlds and drags on the surface of the oceans. Water rises toward it, forming a bulge that follows the Moon as it moves overhead. But the Earth beneath that bulge is spinning faster than the Moon orbits. The tidal bulge slides ahead, just slightly, carried forward by the rotation of the planet itself, and the Moon pulls back on it. That pull is a brake, gentle, distributed across the entire surface of the world, but relentless. The Earth is slowing. Right now, today, the length of an Earth day is increasing by approximately 1 7/10 of a millisecond every 100 years. You will never notice it. No one alive today will live long enough to feel the difference. But the Moon does not need you to notice. It has been pulling for billions of years, and it will continue pulling long after every clock we have ever built has crumbled into dust. At the current rate, it will take roughly 200 million years for a single day on Earth to stretch from 24 hours to 25. 200 million years. Longer than the time separating us from the earliest dinosaurs. Longer than the existence of flowering plants. The Moon is not in a hurry. It is simply doing what the law demands. Angular momentum cannot vanish. When the Earth loses rotational speed, that motion does not disappear. It transfers. The Moon drifts slowly outward, receding from the Earth at a rate of a few centimeters each year, its orbit widening as the Earth's spin slows. The total angular momentum of the Earth-Moon system remains exactly what it has always been. The motion simply moves from one object to the other. But the Moon has not always been slowing the Earth. The Moon itself has already stopped. It reached the end of its own slowing long ago. It shows the same face to Earth at all times now, locked in place by the same tidal forces it now exerts on us. One side of the Moon is always turned toward the Earth. The other side remains forever hidden, not because it is dark, but because the Moon has already arrived at the destination the Earth is slowly moving toward. Perfect synchronization. One face, one orbit, one rotation, all locked together. The Moon spins exactly once for every orbit it completes. It has no choice. The law will not let it do otherwise. The Earth is drifting toward that same fate. Slowly, imperceptibly, but inevitably, billions of years from now. If nothing else intervenes, the Earth will turn only once per orbit around the Moon, and the Moon will hang motionless in the sky above one hemisphere, never rising, never setting, simply fixed in place like a second, smaller sun that never moves. The other half of the Earth will never see it at all. The day and the month will have become the same length. The system will have reached equilibrium. The exchange will be complete. But we are not there yet. We are still in the middle of the process. And the Earth remembers where it started. 400 million years ago, when the first forests were beginning to spread across the continents, and fish were learning to breathe air, a day on Earth lasted only 22 hours. The planet was spinning faster. There were more than 400 days in a year. The Moon was closer. The tides were stronger. The pull was sharper. And the Earth has been slowing ever since. We know this not from theory but from evidence. Ancient corals, long since turned to stone, carry growth rings in their skeletons. Each ring marks a single day. Each band of rings marks a year. The corals grew in layers, day by day, season by season, recording the passage of time in calcium carbonate. And when scientists count the rings, they find more days per year the further back they go. The corals do not lie. They are physical proof that time itself was different. The day was shorter. The year held more sunrises. The Earth turned faster because the Moon had not yet taken as much of its motion. The process is so gradual that no civilization will ever witness a meaningful change. But it is not theoretical. It is not a model. It is happening now, in the oceans beneath you, in the gravitational field stretching between two worlds. The Moon pulls. The Earth slows. The motion transfers. The law holds. And the law does not care about convenience. It does not care that we built our calendars and our clocks around a day that is 24 hours long. The Moon will continue pulling. The Earth will continue slowing. In another 400 million years, if the Earth is still here, if the sun has not changed, if nothing catastrophic intervenes, the day will be longer still, perhaps 26 hours, perhaps more. The Moon will be farther away, the tides will be gentler, and whatever walks the surface of the Earth at that time, if anything does, will live in a world where the day is not the same length it is now. But they will not feel the difference any more than you feel the ground moving at 1674 kilometers per hour beneath you right now. They will simply live in the day they are given, as you do, unaware that the length of that day is not fixed, that it has never been fixed, that it is only a temporary arrangement between two objects exchanging motion across the void. The Moon is not stealing anything. It is not taking something that belongs to the Earth. It is simply participating in the same exchange that has governed every rotating object since the beginning. Angular momentum moves. It transfers. It shifts from one body to another. But it does not vanish. The universe has no mechanism to make it disappear. And so the Moon continues to pull. The Earth continues to slow. The motion continues to transfer. And the day continues to lengthen. One imperceptible fraction at a time. Too slowly for any human life to measure, but fast enough that the rocks remember, and the corals remember, and the gravitational field between two worlds remembers every single moment of the exchange. The Moon has already stopped. The Earth is still turning. But it is turning more slowly now than it was yesterday, and more slowly yesterday than the day before, and more slowly this year than it was 400 million years ago when the corals were growing, and the day was 22 hours long, and the Moon hung larger in the sky, closer and brighter, and pulling harder on the water below. The process is not violent, it is not sudden, it is simply inevitable. The law allows no other outcome. The Moon pulls, the Earth slows, the motion moves from one to the other, and the day grows longer, 1 7/10 of a millisecond at a time, century after century, until the Earth finally matches the Moon and the exchange is complete and both worlds turn together, locked in place, facing each other across the same gap they have always occupied, no longer exchanging motion, because there is no motion left to exchange. But that day is not today. Today the Earth is still spinning faster than the Moon orbits. Today the tidal bulge still slides ahead. Today the Moon still pulls back. And today, the day is still growing longer. So slowly that you will never notice, but so surely that the universe has already written the outcome into the fabric of space itself. The Moon is slowing everything down. And nothing in the cosmos can stop it. When a massive star reaches the end of its life, when the nuclear fire in its core finally exhausts itself and gravity takes over, something extraordinary happens. The star does not simply vanish. It collapses inward, crushing matter down to densities so extreme that protons and electrons merge into neutrons, and what remains is a sphere no wider than 20 kilometers across. The entire mass of a sun, compressed into something smaller than the distance you could walk in an afternoon, and in that collapse the universe remembers. Every star that ever lived carried angular momentum. It turned, slowly, through the dark, the way all things turn when they form from clouds that could only fall sideways. That spin was written into the star from the moment it ignited, inherited from the rotating disk of gas and dust that gave it birth. The star may have turned once every few weeks, a stately rotation imperceptible to any observer watching from a distance. But that motion was there, woven into the fabric of the star itself, and when the core collapses, that angular momentum does not disappear, it cannot. There is no mechanism in the universe to erase it, so it remains, compressed into a neutron star that now spins with a speed no human-scale object could ever sustain. Most neutron stars rotate a few times each second. That is already fast, faster than anything you have ever watched turn. But some neutron stars spin hundreds of times per second, and the reason is simple. They are not alone. They orbit a companion star, close enough that material streams from the companion onto the neutron star's surface, spiraling inward in a disk so hot it glows in X-rays. And with that material comes angular momentum. The companion star is not just feeding the neutron star mass, it is feeding its spin. Every particle that falls carries motion, and the neutron star remembers every particle. Its rotation accelerates. The transfer is silent, invisible to the naked eye, but it is as precise as anything in the cosmos. Angular momentum moves from one object to another, and nothing is lost. In the constellation Sagittarius, near the crowded core of the Milky Way where stars are packed so tightly that the night sky would never grow dark, there is a neutron star catalogued as PSRJ 1748 to 2446 AD. It was observed in detail in 2004 and again in 2005, using the Green Bank telescope in West Virginia. The measurements confirmed something remarkable. This neutron star rotates 716 times every second. Not every minute, every second. Its surface moves at a significant fraction of the speed of light. The horizon would blur into a continuous ring. Day and night would cease to have meaning. The pulses it emits are so regular, so geometrically perfect, that when the first pulsars were discovered in 1967, astronomers did not immediately know what they were looking at. The signals repeated with a precision no natural object was expected to possess. They arrived like the ticking of a clock, each pulse separated from the next by an interval so constant it could be measured to 9 decimal places. For a brief time, the sources were labeled LGM Little Green Men. The possibility was considered that these were beacons from another civilization, navigation markers left by travelers who had passed through the galaxy long before humans existed. But the natural origin was soon identified. These were not signals, they were lighthouses. Neutron stars with magnetic fields so strong they channel radiation into beams, sweeping across space with each rotation, and we see a pulse every time the beam crosses Earth. The regularity was not artificial, it was the signature of angular momentum preserved with absolute fidelity across billions of years. PSRJ 1748 to 2446 adds spins 716 times per second because it remembers. It remembers the rotation of the star it once was, a massive sun that turned slowly through the dark for millions of years before its core collapsed. It remembers every gram of material it has pulled from its companion, every stream of gas that spiraled inward and added its motion to the growing sum. It remembers the angular momentum of the disk from which both stars formed, 5 billion years ago or more, when the cloud that would become this binary system could only fall sideways. The universe compressed all of that memory into 20 kilometers, and the result is not chaos, it is precision. A clock more accurate than anything humans built until the invention of atomic timekeeping. A rotation so stable that astronomers initially mistook it for an artificial signal. This is not violence, it is inevitability. When the core collapsed, the star did not explode into randomness. It contracted into a geometry so tight that every unit of spin it had ever carried was forced into a smaller and smaller radius. And because angular momentum cannot be destroyed, the only possible outcome was faster rotation. The same principle that governs a figure skater pulling in her arms governs the death of a star. The mathematics are identical. The neutron star spins faster because the universe simply remembered every unit of spin the star ever had and compressed it into 20 kilometers. The motion that was once spread across a sphere hundreds of thousands of kilometers wide is now concentrated into a sphere you could drive across in half an hour if there were a road. You cannot see this happen. Even if you were somehow present, the collapse would be over in less than a second. The core implodes, the outer layers rebound, and in the space between one heartbeat and the next, a neutron star is born. But the result lasts for billions of years. The neutron star continues to spin, slowing only imperceptibly as it radiates energy away, in the form of magnetic waves and gravitational ripples. It will still be spinning long after the sun has exhausted its fuel. It will still be spinning when the Milky Way collides with Andromeda and the two galaxies merge into one. It will spin until the universe itself grows so cold and so empty that no new stars can form. And even then it will not stop completely. It will only slow asymptotically, toward a stillness it may never fully reach. The fastest spinning neutron stars are not the youngest. They are the ones that have been fed. The ones that orbit close enough to a companion to receive a steady stream of material, and with it, angular momentum. The transfer can continue for millions of years, longer than humans have walked upright, longer than the continents have held their current shapes. The neutron star grows heavier, and it spins faster, and the record of every particle it has ever captured is written into its rotation. Nothing is forgotten. The universe has no mechanism for forgetting. Angular momentum can move between objects, but it cannot be erased. And so the neutron star becomes an archive, a physical record of every interaction it has ever experienced, encoded in the speed at which it turns. When you lay still tonight, the ground beneath you is turning at 1,674 kilometers per hour. The moon is pulling on the oceans, slowing that turn by a few milliseconds every century. The sun is carrying the Earth around the center of the galaxy, completing one orbit every 225 million years, a journey so slow that the last time we occupied this position in space, dinosaurs had not yet appeared. And somewhere in the constellation Sagittarius, a neutron star no wider than a city is rotating 716 times every second, because it remembers a star that died, and a companion that fed it, and a cloud that collapsed 4.5 billion years ago. The spin is not new, it is inherited. Every rotation you have encountered tonight, from the ground beneath you to the galaxy turning on something invisible, is the same motion, passed from object to object, transformed but never destroyed. The neutron star learned to spin the way the Earth learned to spin, the way the solar nebula learned to spin. It fell inward, and the universe remembered, and the only possible outcome was motion. Rotation is not something the cosmos does. It is something the cosmos is. It is the memory of every asymmetry, every collision, every cloud that ever collapsed. And it continues, without effort, without end, because there is no way for it to stop. You do not need to remember this. The universe remembers for you. You can close your eyes now. The neutron stars will keep spinning. The galaxies will keep turning. The motion that began before the first star ignited will continue, long after the last star fades. And you, who have listened this far, can finally be still. The Milky Way galaxy completes one full rotation in 225 million years. The Sun rides a slow current through space at 230 kilometers every second, tracing an orbit so vast that the last time it occupied this exact position in the galaxy, dinosaurs had not yet appeared on Earth. The entire Triassic period has unfolded, vanished, and been buried in stone since the Sun was here before. The Jurassic came and went. The Cretaceous ended in fire and darkness. Mammals rose from the wreckage and spread across continents. And still the Sun has not completed a single lap around the galactic center. All of human history fits inside the final fraction of a single degree of arc along that immense circuit. You could sleep for 1,000,000 years and wake to find the galaxy almost exactly where you left it. The stars around you would have shifted slightly in their positions, drifting like boats on an impossibly wide ocean, but the great spiral arms would look the same. The core would still glow in the same direction. The turn is so slow it becomes a kind of stillness, motion stretched so thin across time that it feels like permanence. 1,000,000 years is less than half of 1% of a galactic rotation. The Milky Way would have turned through barely a whisper of an angle, a movement too small to register against the backdrop of the cosmos. And yet the galaxy is turning. It has never stopped. Every star in the disk moves along its own curved path, held in orbit by the combined gravity of everything else, and every one of them carries the angular momentum it inherited from the cloud that collapsed to form them billions of years ago. The spin that began when the galaxy was nothing but gas and dust is still here, transferred from particle to particle, star to star, preserved across eons, because the universe has no mechanism to erase it. The galaxy remembers the motion it was given at birth, and it will carry that memory until the stars themselves grow cold. Every spiral galaxy we can see turns the same way, driven by the same principle, each one a slowly rotating island of light in the dark. But something strange happens when we measure how fast the outer stars are moving. By every law of gravity we understand, stars at the edge of a galaxy should orbit much more slowly than stars near the center, the way Neptune takes 165 years to circle the Sun while Mercury completes its orbit in just 88 days. Distance should slow them down, but it does not. The rotation curves of spiral galaxies are flat. Stars at the outer edge move at nearly the same speed as stars close to the core, as though something invisible is holding them in place. Astronomer Vera Rubin spent years in the 1970s and early 80s mapping the velocities of stars in spiral galaxy after spiral galaxy, measuring the light from distant suns, and calculating how fast they moved. The pattern held in every case. The galaxies were spinning too fast to be held together by the matter we could detect. The visible stars, the glowing gas, the dust lanes threading through the arms, all of it together was not enough. Something else had to be there. We call it dark matter, because we have no better name for what we cannot see. It does not emit light. It does not absorb light. It does not interact with ordinary matter, except through gravity, the bending of space itself. But its presence is written into the motion of every galaxy we observe. The flat rotation curve is not a theory or a guess. It is a measurement, repeated thousands of times across the sky, and the conclusion is always the same. Something invisible holds the stars in their orbits, a scaffolding of mass distributed throughout the galaxy in a vast halo that extends far beyond the visible disk. The Milky Way is no exception. The Sun orbits the galactic center at 230 kilometers per second, held in its path by the gravity of roughly 1 trillion stars, and an even larger mass of dark matter, woven through the galaxy like a net we cannot see, but can trace by the way everything moves within it. The visible stars account for only a fraction of the total mass. The rest is dark, silent, detectable only by its gravitational pull on the things that shine. The galaxy rotates as a whole, but not like a solid wheel. Different parts turn at different rates. Stars closer to the core complete their orbits more quickly in absolute terms, circling the center in tens of millions of years. The result is a slow, stately shearing motion, the spiral arms winding and unwinding over time, reforming as waves of density move through the stars like ripples on a pond. The arms themselves are not fixed structures. They are patterns, regions where stars and gas crowd together briefly, where the density rises just enough to trigger bursts of star formation that light up the arm in blue and white before fading again as the stars drift apart. The Sun has passed through several spiral arms in its lifetime, moving in and out of these regions of higher density, like a traveler crossing rivers on a long journey. It takes 225 million years for the Sun to return to the same position relative to the galactic center, but the galaxy itself is not standing still. It is moving through space, falling slowly toward the center of the local group, a small cluster of galaxies bound together by gravity. The Milky Way and the Andromeda Galaxy are the two largest members, and they are drifting toward each other at roughly 110 kilometers per second. In about 4 billion years they will collide, their stars passing through each other like two clouds of smoke interpenetrating, their dark matter halos merging, their angular momentum redistributing as they spiral together and eventually settle into a single larger galaxy. The collision will not destroy the stars. Space is too empty for that, but it will reshape the orbits of billions of suns, scattering some into new trajectories, pulling others toward the merged core. Even then, the total angular momentum will be preserved. The two galaxies will bring their individual spins into the collision, each one carrying the rotation it inherited from the clouds that formed it more than 13 billion years ago, and the resulting galaxy will inherit the sum of both. The spin will be twisted, redistributed, mixed into new orbits and new patterns, but it will not vanish. The universe will remember every unit of rotation both galaxies ever had, and the new galaxy will carry that memory forward in the motion of its stars. The Milky Way turns so slowly because it is so large. Angular momentum depends not only on speed but on distance from the center of rotation. A galaxy hundreds of thousands of light-years across, its stars spread thin across an ocean of space, can carry an enormous amount of angular momentum, even while turning at a pace so gradual it seems almost frozen. The Sun has completed only about 20 orbits since the galaxy formed. 20 laps around a track so vast that a single circuit takes longer than the entire age of the dinosaurs. 20 rotations in more than 13 billion years of existence. You are standing on a planet that completes one rotation every 24 hours. A world that spins fast enough that the ground beneath you rushes eastward at 1,674 kilometers per hour. That planet orbits a star at 30 kilometers per second. The star itself moves through the galaxy at 230 kilometers per second, carrying its retinue of planets along an orbit so enormous that it will not return to this position for 225 million years. And the galaxy is falling toward Andromeda at more than 100 kilometers per second, drawn by gravity across the gulf between them. Every layer of motion is real. Everyone is driven by angular momentum, inherited from the structures that came before, motion that cannot be destroyed, only passed from one object to another across the span of cosmic time. And yet you feel none of it. You are still. The cosmos turns around you, layer upon layer of rotation stacked one inside the other, and you do not move. The motion is so vast and so slow that it becomes invisible, woven into the fabric of space itself. The galaxy will not finish its current turn for another 200 million years. You will not be here to see it. No one you know will be here. No civilization now standing will likely endure that long. But the galaxy will continue, patient and inexorable, carrying the memory of every spin it was ever given, turning in the dark while you rest. You have already been moving through this pattern since the moment you were born. The ground that spins beneath you at 1674 kilometers every hour, the moon that pulls at the oceans and slows the turning of the day, the star that collapsed into a sphere 20 kilometers wide and learned to spin 700 times each second, the galaxy that takes 225 million years to complete a single rotation around a center, made mostly of something we cannot see. All of these follow the same principle. Angular momentum moves from one object to another, but the universe holds no mechanism that can make it vanish. What was given at the beginning is still here. The cloud that fell sideways and became the solar system obeyed this law. The collision that gave Earth its seasons and its moon obeyed this law. The tidal drag that lengthens every day by less than 2 milliseconds each century obeys this law. The neutron star that spins so fast and so precisely that astronomers first mistook its signal for something artificial obeys this law. The Milky Way, turning so slowly that the Sun has circled it only once since the Triassic, obeys this law. There is no exception. You are not separate from it. You are made of atoms that were forged inside stars that also rotated, collapsed and expelled their material into the dark. Those stars obeyed the same principle. They spun as they burned. They spun faster as they collapsed. When they died, they scattered their contents across light years of space, and those contents carried the memory of every rotation, every transfer, every collision that had shaped them. The iron in your blood was formed in a star that turned. The calcium in your bones was born in a supernova that remembered its spin, even as it tore itself apart. The oxygen you breathe was made inside a massive star, whose core collapsed under its own weight, and, in collapsing, spun faster, because it had no choice. The atoms that compose you drifted through the galaxy for millions of years, before they gathered in the disk that became the solar system. They were part of the cloud that could only fall sideways. Material near the poles fell straight inward toward the center. Material near the equator could not fall in a straight line. It could only fall sideways, tracing wider and wider circles until it settled into a flat plane around the young sun. Every planet that formed from that disk orbits in the same direction because they all remember the same original spin. The atoms in your body were there. They fell with everything else. When you stand on the surface of the Earth, you are standing on a platform that moves at 1674 kilometers every hour, and you do not feel it because you are part of the motion. You inherited it. You were born into a system already turning, and every atom in your body obeys the law that governs that turn. At the poles, the ground moves nowhere at all. But at the equator, the surface sweeps through space faster than the speed of sound, and you cannot feel it. You never could. Everything around you moves at the same rate simultaneously, held in place by gravity, synchronized perfectly with the spin of the planet beneath. This is not metaphor. This is the same principle that forced the solar nebula to flatten into a disk, that gave the Earth its 5-hour day after the collision with Theia, that pulls the Moon slowly outward and the day slowly longer, that compresses a collapsing star into something so dense and so fast that it completes 716 rotations in the time it takes you to blink. You are made of the same material. You are subject to the same law. The tilt that gives Earth its seasons is the scar of a collision that happened 4.5 billion years ago. The 23.5-degree angle at which the planet leans as it orbits the Sun is the record of an oblique collision between the early Earth and a Mars-sized body that struck at roughly 45 degrees, ejected a disk of molten rock and vapor into orbit, and left the planet spinning so fast that a day lasted only 5 hours. That collision is still written into the motion of the Earth. Every sunrise carries its memory. The angular momentum delivered in that moment has never left. It has only moved. The Moon now holds some of it. The rest remains in the spin of the Earth itself, slowing gradually as the Moon pulls back on the tidal bulges, centimeter by centimeter, year by year. The Moon has already arrived at the destination the Earth is slowly moving toward. It shows the same face to us at all times, because it reached tidal locking long ago. The Earth is drifting toward that same state, but it will take billions of years. Coral fossils from 400 million years ago still preserve the evidence of a shorter day. Growth rings laid down in cycles of 22 hours, more than 400 days in a single year. The day was shorter then, the Moon was closer, time itself was different. But the total angular momentum of the Earth-Moon system was the same. It has only been redistributed. The law does not care how long it takes. It simply continues, inexorable and patient, rewriting the length of the day at a rate of 1.7 milliseconds per century. The galaxy turns around a center we cannot see, held in place by something invisible that we call dark matter only because we have no better name for what we cannot detect. The rotation curves of spiral galaxies are flat. Stars at the outer edge orbit at nearly the same speed as stars near the center. By Newtonian gravity alone, the outer stars should move much more slowly. They do not. Something holds them in place. The Milky Way has been turning for more than 13 billion years, and it will continue turning long after the Sun dies, long after the Earth is gone. But the angular momentum will remain, it will move, it will transfer, it will never disappear. You do not need to hold on to it. The universe does that for you. Every rotation you have ever witnessed, every turn of the Earth beneath your feet, every orbit of the Moon around the planet, every sweep of the Sun around the galactic center, is the same motion that began billions of years ago and has never stopped. It does not need your attention. It continues whether you are awake or asleep, whether you are watching or dreaming, whether you remember it or forget it entirely. The law that governs all of this was not invented by anyone. It was not decided. It is a consequence of the symmetry of space itself, the fact that the laws of physics are identical no matter which direction you face. A mathematician named Emmy Noether proved this in 1918. She showed that if space is symmetric in this way, then angular momentum cannot be destroyed. It is built into the structure of reality. Even a jagged, broken rock tumbling through the void obeys this law perfectly. It is not the object that needs to be symmetric. It is the space through which the object moves. You are already obeying it. You have been obeying it your entire life. Every step you take, every breath you draw, every motion of your hand happens on a platform spinning at 1,674 kilometers every hour, orbiting a star at 30 kilometers every second. circling a galactic center at 230 kilometers every second. And you feel none of it because you are part of the system. You are not watching the pattern from outside, you are inside it, you are made of it. The same atoms that turned inside dying stars billions of years ago are turning inside you now. The universe remembers every unit of spin it was ever given. It remembers the collapse of the cloud. It remembers the collision that made the moon. It remembers the star that died and seeded the space between the stars with iron and carbon and oxygen. It has written that memory into the motion of every object that exists. You are part of that record, you are part of that memory, you are already spinning. Spin is not movement, it is memory. Every object turning tonight carries the exact record of what happened to it billions of years ago. The ground beneath you moves at 1,674 kilometers per hour because a cloud of gas collapsed sideways 4.5 billion years ago, and there has been no mechanism since then to make that motion disappear. The day lasts 24 hours because a Mars-sized body struck the Earth at an angle and threw molten rock into orbit, and the moon that formed from that debris has been pulling on the oceans ever since, slowing everything down by 1.7 milliseconds every 100 years. The coral fossils from 400 million years ago still carry growth rings that record a 22-hour day. The rock remembers. The neutron star that spins 716 times every second remembers the enormous star it used to be. When the core collapsed to 20 kilometers across, the universe simply compressed all of that original spin into something smaller than a city, and the star began to turn so fast that astronomers mistook its signal for something artificial. It was not intelligence, it was geometry. It was the same law that makes a skater spin faster when she pulls in her arms, carried to stellar scale. The star did not choose to spin that way. It inherited the motion from everything it had ever been. The Sun circles the center of the Milky Way once every 225 million years. The last time it occupied this exact position in the galaxy, dinosaurs had not yet appeared on Earth. The galaxy turns so slowly you could sleep 1,000,000 years and miss nothing. And yet it turns with the same precision as the neutron star, obeying the same principle. The outer stars orbit at nearly the same speed as the stars near the center, even though gravity alone would make them drift more slowly. Something invisible holds them in place. We call it dark matter because we have no better name for what we cannot see. But whether we see it or not, the galaxy remembers. Every spiral arm, every star, every cloud of gas turning in the dark carries the angular momentum it was given when the galaxy first formed, and there is no way for that motion to be lost. You are already part of the pattern. The atoms that make up your body were forged inside stars that also rotated, collapsed, and expelled their material into the cosmos. Those atoms carried the memory of that spin with them. They fell into new clouds, they collapsed again, they became the disk that became the planets. They became the ground beneath you, they became you. The universe forgets nothing. A mathematician named Emmy Noether proved in 1918 that this is not a rule someone invented. It is a consequence of the shape of space itself. The laws of physics are identical no matter which direction you face, and if that symmetry holds, then angular momentum cannot be destroyed. It is not optional. It is not a choice the universe makes, it is what the universe is. Even a jagged, broken rock tumbling through the dark obeys this law perfectly. It is not the object that needs to be symmetric, it is the space through which it moves. And because space has no preferred direction, every unit of spin the rock was ever given stays with it. The rock may shatter, it may melt. It may fall into a star and be torn apart by gravity. But the spin does not vanish. It moves from one fragment to another. It is inherited. It is passed down. It is remembered. The Moon has already arrived at the destination the Earth is slowly moving toward. It shows the same face to us at all times, because it reached tidal locking long ago. Billions of years from now, if nothing intervenes, the Earth will do the same. One face will always point toward the Moon. The day will match the month. The two bodies will turn together, locked in a dance they can never leave, because the angular momentum they share can move between them but can never be destroyed. This is what conservation means. Not that things stay the same, but that the universe keeps a perfect accounting. Every collision is recorded. Every cloud that ever collapsed is still turning in the objects it became. The solar system orbits the way it does because every planet formed from the same rotating disk, and they all remember the same original spin. The tilt that gives us our seasons is the scar of a collision 4.5 billion years ago. The 5-hour day that followed that impact has been stretched by the Moon into the 24-hour day you woke into this morning, and it will continue to stretch 1.7 milliseconds per century for hundreds of millions of years to come. You cannot feel the ground moving beneath you. You never could. But it is moving, and it will continue to move, because the universe has no mechanism to stop it. The probability of the Earth stopping its spin in the next several billion years is practically zero, not because something is holding it in place, but because there is nothing that can take the motion away, and you, who have followed this turning from the beginning to here, can now be still. The universe will keep spinning for you. The galaxy will complete its 225 million year turn, whether you are awake or asleep. The Moon will continue to pull on the oceans. The neutron stars will keep their perfect time. The ground will carry you at 1,674 kilometers per hour through the night, and you will not need to do anything at all. The motion is not yours to maintain. It was given long before you were born, and it will continue long after you are gone. The universe remembers. You can rest. The ground beneath you is moving at 1,674 kilometers per hour. It has been moving that fast your entire life. You cannot feel it. You never could. The air moves with you, the buildings, the trees, everything synchronized to the same silent turning. At the poles, the ground moves nowhere at all, rotating in place like a ballerina's finger held above her head. But here, wherever you are now, you are already in motion. The Earth will not stop. NASA calculates the probability as practically zero for the next several billion years. This is not a choice the planet makes each morning. It is inheritance. Lower the lights, put on your headphones. This motion obeys a law that was written into the structure of space itself before the first star ignited. Angular momentum can move from one object to another, but the universe has no mechanism to make it disappear. In 1918, a mathematician named Emmy Noether proved this is not a rule someone invented. It is a consequence of the shape of space itself. The laws of physics are identical no matter which direction you face. If that symmetry holds, and every measurement ever taken confirms that it does, then angular momentum cannot be destroyed. It is not optional. Einstein praised her theorem as an example of penetrating mathematical thinking, and it became a standard tool of theoretical physics, but the truth it describes is older than theory. Even a jagged, broken rock tumbling through the dark obeys this law perfectly. It is not the object that needs to be symmetric, but the laws governing its motion. 4.5 billion years ago, the solar system did not exist. In its place was a cloud of gas and dust several light years across, drifting through the void with a slow, inherited spin. gravity, began to pull the cloud inward. As it contracted, it had nowhere to put the angular momentum it carried. The universe offered no mechanism to shed it, so the cloud did the only thing it could: it spun faster. Material near the poles fell directly inward toward the center, but material near the equatorial plane could not fall in a straight line. It could only fall sideways. The cloud collapsed into a flat, rotating disk around the young sun, and from that disk the planets formed. Every planet orbits the same way because they all remember the same original spin. The motion you feel beneath you now, 1,674 kilometers per hour at the equator, is the motion of that ancient cloud, transferred through 4.5 billion years without loss. But the Earth does not spin the way it did when it first formed. Every sunrise carries the memory of a collision. The leading theory holds that approximately 4.5 billion years ago, a Mars-sized body struck the early Earth at an oblique angle. The impact was not head-on. It came in at roughly 45 degrees, and the collision ejected a disk of molten rock and vapor into orbit. That material coalesced into the Moon. Immediately after the impact, an Earth day lasted only 5 hours. The tilt that gives us our seasons, 23.5 degrees, is the scar of that collision. Without it, Earth might have had no axial tilt, and therefore no seasons. The Moon is not a companion that happened to wander near. It is a piece of the Earth, thrown into orbit, and it has been rewriting the planet's rotation ever since. The Moon's gravity drags on Earth's oceans, creating tidal bulges. Because Earth rotates faster than the Moon orbits, the tidal bulge sits slightly ahead of the Moon in its path. The Moon pulls back on this bulge, slowing Earth's rotation. The day is currently lengthening at approximately 1.7 milliseconds per century. You will never notice. No human lifetime is long enough to feel the difference. But the record is written in stone. 400 million years ago, a day on Earth lasted only about 22 hours, and there were more than 400 days in a year. Growth rings in ancient coral fossils prove this. Each ring marks a day, each band of rings marks a year. The coral kept time, and the time was different. At the current rate, it will take approximately 200 million years for an Earth day to reach 25 hours. The Moon has already arrived at the destination the Earth is slowly moving toward. It shows the same face to Earth at all times, locked in place, its rotation and orbit synchronized. Earth is drifting toward that same stillness, 1.7 milliseconds per century, and the Moon will not stop pulling until the planet matches its pace. When a massive star exhausts its fuel, the core collapses. The outer layers may explode outward, but the core falls inward, compressing into a sphere approximately 20 kilometers in diameter. All of the original star's angular momentum is preserved in that small object. The universe simply remembered every unit of spin the star ever had, and compressed it into 20 kilometers. Most neutron stars rotate a few times per second. But neutron stars in binary systems can spin hundreds of times per second, because their companion stars transfer angular momentum to them through accretion. The record for the fastest spinning confirmed pulsar is held by a neutron star designated PSRJ 1748 to 2446 AD, observed rotating at 716 times every second, with a regularity so perfect that astronomers initially mistook it for an artificial signal. When the first pulsars were discovered in 1967, the signals were so geometrically precise that astronomers provisionally labeled them LGM, little green men, before the natural origin was identified. But there is no intelligence required to produce this precision, only the law. The star collapses, the spin remains, the universe forgets nothing. One galactic year, The time for the Sun to complete one orbit around the center of the Milky Way is approximately 225 million Earth years. The solar system travels at an average speed of 230 kilometers per second along this path, and yet the motion is so slow that you could sleep a million years and miss nothing. The last time the Sun occupied this exact position in the galaxy, dinosaurs had not yet appeared on Earth. The rotation curves of spiral galaxies are flat. Stars at the outer edge orbit at nearly the same speed as stars near the center. By Newtonian gravity, outer stars should orbit much more slowly. They do not. Something invisible holds them in place. We call it dark matter because we have no better name for what we cannot see. The rotation curve is confirmed. The explanation is the best we have. But whether the invisible mass is real or whether gravity itself behaves differently at galactic scales, the galaxies turn, and they turn according to the same law that governs the collapse of a cloud, the orbit of a planet, the slowness of a day. You are already part of the pattern. The ground beneath you is moving at 1,674 kilometers per hour because a cloud collapsed 4.5 billion years ago and had nowhere to put its spin. The moon is slowing that motion because a collision threw it into orbit, and angular momentum moves between objects but cannot be destroyed. The atoms that make up your body were forged inside spinning stars that collapsed, expelled their material into the cosmos, and obeyed the same principle at every stage. You are made of atoms that were born inside spinning stars. You are standing on a planet that remembers a collision. You are orbiting a star that is orbiting a galaxy, and the galaxy is turning on something invisible, and all of it, every rotation from the ground beneath you to the 225 million year turn of the Milky Way, obeys the same single law. Spin is not movement, it is memory. Every object turning tonight carries the exact record of what happened to it billions of years ago. The cloud that collapsed, the impact that tilted the Earth, the companion star that fed angular momentum to a collapsing core. The universe forgets nothing. And you, who have followed this turning from the beginning to here, can now be still. The Earth will keep spinning, the moon will keep pulling, the galaxy will keep turning. The universe will remember for you. You do not need to hold on to any of it. The motion is inherited, and it will continue long after you wake. Let it go. The cosmos is the cartographer of its own memory, and every rotation is a line drawn on a map that no one needs to read tonight. Close your eyes. The spin will be here in the morning. A line across the dark. You followed the motion from the ground beneath your feet to the edge of the galaxy, through collisions that rewrote the length of the day, and collapses that compressed a star's entire history into 20 kilometers. Every turn you traced tonight obeys the same law. Angular momentum moves between objects, but the universe has no mechanism to make it disappear. Spin is not movement. It is memory. Every object turning tonight carries the exact record of what happened to it billions of years ago. If you stayed awake this long, thank you. If you fell asleep somewhere along the way, that was always the invitation. Wherever you are tonight, the ground is still moving, the moon is still pulling, the galaxy is still turning on something we cannot see. The dark will still be here, so will I. Come back tomorrow night.